Hey, I'm Bonner Harris, and welcome to Door Talk.
Hey guys, welcome back to Door Talk. We're excited to have you back with us today. We're continuing our series on architectural wood doors and all the other types that we have out there of wood doors. And today we're going to be talking about mainly wood door construction or architectural wood door construction. We've got Wally Berry back with us today as a special guest. We're excited to have him with us. So Wally, let's hop right back into it. Let's talk about the construction of an architectural wood door, what the different types of construction there are.
Absolutely. Thank you, Austin. I'm glad to be back with you. So when we talk about an architectural door and the construction options that are there, when you talk about layup, there are two options that are out there. And when I say layup, what I'm talking about is when you build the door implies you have a face with a backer, you have core and perimeter materials, and you have another face that goes on top. So you're kind of building a Oreo cookie, as it were, right? You have your face, your cream middle, and then your face. That's your door ply layers. Okay. So when we talk about this, there's two different ways to do it. Way one is what's called loose layup or a drop-in core. And what happens is you take your door face, you lay it down on a table, and then you send all of your components through a glue spreader, right? You're using different manufacturers use different systems for this, but they go through and they're laid onto the back of this door skin independently. And then that other skin gets laid on top, and then you just keep building your stack of doors. That's called loose layup. Difficulty with that is you end up with a limited warranty requirement, but you also end up with a high propensity for what's called telegraph or show through. WDMA and others, they have a requires industry standard that allows for that. However, it's a pretty minor allowance. So you've got to be careful when you're building these doors. If you're going to build an architectural grade door, the recommendation is not to go with a loose layup due to this. So that would fall more maybe into a light commercial or just a standard commercial application. If you're going to go into an architectural or an institutional type construction, we're going to talk about bonded construction. And what we want to do is we're going to take that same door skin and we're going to lay it down. And now we're going to take the core, whether it be particle board, structural composite lumber, mineral core, whatever the core selection is, and we're going to run it through a machine that's going to put all of the perimeter components and attach it to it before it even gets to the door face. Wow. Then we're going to put the adhesives on that, and then we're going to put it in there and put that other face on and press it. Okay, so now you get this door that has a minimized capability for telegraph or show through. It helps acclimation in a great way, but it also gives you a lifetime warranty. So it's starting to meet now what that architectural specification is, right? So when you talk about that, we've now built a door that talks about it could be a 5-ply, it could be a 7-ply, it could be a 3-ply, depending on what skin is specified and how the construction is, that now has a lifetime warranty, which has the proper dimensions of edge components, top and bottom rail, as well as blocking materials. So when you talk about architectural doors, we talk about fire rated doors, right? We're going into fire rated applications. You better be careful of blocking, right? Every fire rated door in NFPA 80 specifically says self-closing, automatic closing, and positive latching. It's a minimum requirement within that standard. So are you going to surface mount a closer onto that particle board core? You can. It just may not have much success over a couple of years, right? So you're either going to have to consider talking about blocking the door properly or through bolting that hardware, right?
And I think we've both seen out in the field before. People they'll take a mineral core door and they think, if it didn't have the proper blocking in it, they'll just screw it straight into the mineral core. And it may work on 1 or 2, possibly 3 openings of that door, but over time that door just ends up pulling right off of or the closer ends up pulling right off the door. And I think the same thing you're talking about, even through bolting through that, it can pull. I've seen it pull the through bolts right through the door. So what you're saying is very important on that, making sure that blocking's there on your fire doors.
Yeah, and not just blocking, the proper blocking,
Yeah.
right? Because manufacturers may choose to use different types of material for blocking material. And I've done enough inspections on job sites. I mean, don't tell anybody, but I've actually physically seen closers that have been glued back onto the surface of a door because
Wow.
the screws pulled out. And you can see the little glue lines underneath the closer. Now, it's not up to me to point that out, because it's like, hey, I'm not here to look at your closer. I'm here to look at your door. I just noticed this. So there are creative ways that people have come up with for this remedy. However, there's right ways to build a door and there's not so right ways to build a door. And so the recommendation is understand your manufacturer that you've chosen to deal with and understand what their blocking capabilities are and what their standards are for blocking, what their minimum requirements are on the materials that they are using for blocking those products, right? Because the longevity, you can't put a door up there with a improper blocking method with a grade 1 closer, right? You have a closer that's warranted for many cycles, and the door is not going to last that many cycles because of this application. So there's different ways to build a door, different ways to have fun with a door. But when we talk about the core of the door, we have a lot of options here as well, right? The basic options when we talk about cores are either going to be a hollow core, right? There are hollow core doors out there. Solid core, which also could be defined as particle board. There's an LD1 and there's an LD2. Most manufacturers, the compliance requirement for an architectural door is A208.1. And you're going to have to use a particle board, which has a density or a PCF rating that meets A208.1, which is about 34 pounds per square inch of density of particle board to be in the core of that door, which is not enough to sustain surface mounted closers or surface mounted exit devices or surface mounted hardware other than kicks and mops. You may be able to get away with that. And then you also have what's called WSL cores, wood stave lumber cores. They're still out there in the industry today. They're not as readily used as they used to be. And now we're going into more of that institutional application, right? When you talk about the WSL core, the wood stave lumber core, and then the SCLC core, the structural composite lumber core. This is the one that has taken over the same performance value as the wood stave lumber. However, it has some higher fire rating capabilities without jumping into that mineral. It has a greater aesthetic performance, and it's got maximum screw holding and withdrawal performance based on WDMA standards. So it's an amazing core to be able to use. I mean, you can literally put this core in a door and get a 45-minute fire rating out of this core without jumping up to that mineral product, right? Now, the caveat is it's not a temporized. So if the specification, if you're in a stairwell or you're in that application where temporized, right, your stairwell has that 2-hour requirement, but it also has a national minimum requirement of 450-30, right? 450 degrees of maximum temperature pass through within 30 minutes of the burn. The structural composite lumber core will not get you there. So you have to go over to now this mineral core. And when you go into a mineral core, that's now going to give you 45 to 90 minute fire rating capabilities for a wood door. It's also going to give you that temporized requirement. So you're going to see that language on your label, right? Because when you talk about these fire rated products, we now have to worry about our language on our labels and make sure that that aspect of it is being met as well. And then you get obviously into specialty cores where you can have sound transmission class cores, right? STC 42s, 43s, 45s, 47s, wood doors. They go up around those upper 40s.
Yeah.
And then beyond that, you're going to get into some creative manufacturers that may use a metal laden product with a wood veneer attached to the surface to get you up into those 50s, 52s, 55s and above, right? So there's a variety of ways to build a door to make sure it's structurally sound and it meets that fire rating or code requirement as well as your hardware mounting applications.
And now your mineral core doors that we were talking about, I've ran into a customer. It was at a nursing home. He was putting a closer back onto the door, and when he took it off, he called us and he was worried. He said, "What is this white stuff coming out of my door?" He said, "I thought these were wood." He's like, "What did y'all put in this?" And we explained to him what it was and everything. But I think that's a something to talk about is if you could explain kind of what mineral core is, what that core is.
Yeah, mineral core is it's kind of a gypsum-based material. So it's very dense. It's manufactured different ways. Some door manufacturers manufacture their own core. Others have to buy their core out. So the weight of a mineral core door from manufacturer to manufacturer could vary. Some have a very dense, very heavy laden core. Some have a mineral, and it kind of looks like drywall. And it's got a variety of binders in it, but it's also a fire retardant. But don't get confused when you talk about the mineral core versus the perimeter materials. It's two different products. So when people go, hey, your mineral, there's no blocking in the end of your door. It's white. I can see white at the edge of my door, and I can see white in the bottom of my door. That's a fire stop material. So that's a material manufactured, number one, for screw holding capabilities, but number two, for structural strength, right? Doors can become very heavy, and next thing you know, you're going to hang this door, say it's a 3070 door, and it's going to weigh somewhere in the range of 120 pounds, right? You're going to put that on 3 butt hinges. You're allowed to use 3 hinges, right? You can use 3 butt hinges. That's not a problem at all because the hinge rule says you can do that. However, you're going to just use a standard weight hinge, or maybe you need to consider a heavyweight hinge, right? But this is a pretty weighty door. And so you remember all that weight's going to be pulling on those edges. So that material that's used, that material that was coming out when he was removing his screws, is not core, because you're not allowed to block or put surface mounted hardware into this core. This core cracks, right? So when you run a screw into this core, it has the ability to pull apart. And if you create a deviation and there is a severe fire, guess what? That is now a weak point of the door. So blocking is required in all aspects for any surface mounted hardware on mineral core doors, whether it be a rim exit device, whether it be an overhead closer, whether it be a surface mounted flush bolts, or not flush bolts, but surface mounted vertical rod carriages. So these are all requirements based on that mineral core.
And now with that, a lot of times there's things called we were discussing earlier, the intumescents that are in the door. If you want to, maybe if we could talk about the difference between what we were talking about with a smoke seal and intumescents.
Certainly. So when you talk about positive pressure, because when you're going into 45 minutes and above, we're now talking about positive pressure testing, right? So now we're talking about, in addition to fire, we're talking about smoke and draft control, right? So you have category A for wood doors, and you have category B for wood doors. And what that simply means is every fire rated door from 20 to 90 minute, we're talking about wood doors, from 20 to 90 minutes is required what's called category H, smoke gasket, right? Because if you think about the reality of it, a 20-minute fire rated door is the only fire rated door in the industry that does not require category G or additional gasketing, right? Because the fire is never getting hot enough within that 20 minutes to want to damage that smoke control gasket. So this additional gasketing does not play a role, or nor is it required unless you're in Canada. Canada does require every fire rated product to have category G gasketing. I don't know if you knew that or not, but if you're going to supply doors to Canada, it's required. So when we talk about this extra gasketing, we're talking about specifically an intumescent. And what an intumescent is, it's kind of like if you go to the fireworks stand and you buy those little black pellets that When you apply heat to them, they turn into a snake, they turn into an ash, right?
Yeah.
They swell up and that's an intumescent. That is a form of an intumescent. So there's two different ways to do it in a wood door. You have category A, and the way to remember this is aesthetics, right? I don't want to see this additional gasketing in my assembly, right? Because you have category A, B, C, D, E, F, G, and all of these talk about the UL listing in the NFP 252, UL 10C, UL 2B requirements for fire rating. And so the category A says, I don't want this additional gasketing to be seen, so I'm going to build it into the edge of my door, and I'm going to conceal it under the veneer and the outer edge band at the head and the vertical edges of the door. This would be used more in a high traffic application, a school application, hospitals, where there's going to be a lot of public use, because what happens when kids get bored? Right? Not to single out children, what happens when people get bored? We want to pick at things. We want to fidget with things. And if somebody's playing next to a door, what do? Oh, there's something I can tear off a door. Well, it's there for a reason, right? And if somebody has removed it because it's a piece of tape and somebody has removed this, and then there's a catastrophe, it's not going to do what it was designed and specified to do. So the safe goal is put that inside the door, and that way the assurance of that happening will happen. But you do have what's called category B, which is budget, that costs a little bit less, and you can buy an additional gasketing material. It's an intumescent tape material. It's inert base, so it will not deteriorate over time. The atmospheric pressure and the air molecules will not deteriorate it. And you apply it to your frame assembly with your category H smoke gasketing, and it does exactly the same thing. And basically, simply put, what happens, Austin, is the fire gets hot at about 100 degrees Celsius. All of a sudden, this material starts to swell up and it turns into foam. And what it does is it fills the gap around the vertical edges of the door and across the top head plane of the door, and it fills it with this foam, and it allows the door to naturally breathe as it would in a fire, because in positive pressure, we're talking about moving the neutral plane of the line to 40 inches above the finished floor, right? That's what the rule says. So we talk about the underside of the door, doesn't require gasketing, negative pressure. Above 40 inches, positive pressure. That 40-inch line, neutral, right? So that's your neutral pressure line. Got to be 40 inches. Back before 1997, this was all the way up at 84 inches or at the top of the frame assembly.
Wow.
Yeah, so they moved it after 1997 down into that 40 inches above the finished floor and realized that fire has a real-time action, right? And you need to allow that underside. Now, are you required to seal under there? No. Can you? Sure. But the more pressure you build up inside that room, because remember, once you put this gasketing in there, that pressure, that smoke and gas will not penetrate through that assembly. It's going to maintain it in that space. That's the whole purpose. If you seal off the bottom of that door, when life safety goes to breach that space, there may be an overflash or a little bit of a problem. And that's why they allow that up to 3/4 inch undercut underneath those fire rated doors to allow that free flow pressure to relieve as the oxygen is consumed, it pushes up, turns into smoke. The smoke cools and it falls down. That pressure starts pushing down, and all of a sudden, that room is filled with pressure. So you have to way to kind of minimalize that. So this extra gasketing is very, very important to those 45-minute and above ratings.
And I think that something that people forget about with what we're talking about with fire doors or firewood doors and stuff like that is that there is a reason and a purpose behind every one of these, the NFP 80 and all that. And a lot of it's geared towards, of course, life safety, but also your first responders being able to do what they need to do. I mean, that's, it's like you were talking about with the wood doors. There's a reason why they changed that back in the 80s, like you're talking about, to be able to let that fire be able to breathe, because otherwise, like you said, a flash fire could happen when they bust open the door and things like that. So, people question us a lot of times, and I'm sure you get the same thing on, well, why does it have to be done that way? Well, there's a lot of different explanations on why it could have to be done that way. But, one thing is because it's for the safety of you and also for the safety of the people who are good, probably trying to help you. So
Yeah, I mean, you have to remember as we're building components that work in an assembly, right? So we all have to be collaborative as an industry. And as we build these components, what we're doing, just like we build doors to WDMA or the AWI-AWS standard, guess what? NFPA, National Fire Protection Association, they write 80 for opening protectives. They write 101 for life safety, right? So now you have NFPA and NFPA 80, 101. You have NFP 252, right? You have the NFC, the National Fire certification requirements. And then you end up with our wonderful ADA, right? So you got A117.1 that now plays a role in there. And then you get ICC IBC, right? So then you have these other standards that are recognized. And so all of this has to collaborate and work together. And if it doesn't, this could be a big problem for everybody.
Wally, thank you so much for being with us again today on this second episode of our series of wood doors. It's been exciting, and we're going to conclude our next episode. It's going to be our last episode on the series. We're going to be talking about the different types of veneers and cuts and all those things to kind of end our series on wood doors. So guys, thank you for joining us today, and we'll see you on the next episode.